So one thing with, guys, based like in the break, I think some people ask this question as to why we need the master role and why we need the slave role. What does the master role achieve? So I believe that this is something which I just need to revisit before we jump on to the actual discussions on the whiteboard. So what the master role does is that, so to understand is that the switches don't connect to just one controller. Each switch or a cluster of switches connect to more than one controller. So one of the controller dies, it's not that I'm making a new handshake with the switch again. There is an active connection between the switch and the other controller. So it's just going to be a role change. So there's no handshake involved, because that was one of the questions. It's not going to be having a handshake involved. There's going to be a standby connection, and a role change is only what is required for a transition from one controller to the other when one of them dies. How soon is going to happen is based on the AKA cluster down event, which I'm not sure probably how much time does it take for the cluster down.
It's very,
yeah, okay, so it's very quick. Yeah. So that's the actual latency which we'll have, where you will switch to a new controller. Second is that what does the master role achieve, and the slave, what the slave does. The master role, you can make read and writes both to the switch, whereas the slaves, you can just get the reads. That's what as per the OpenFlow protocol is. Why we need cluster aware applications? I know this is a very big discussion, and there was a lot of back and forth on this, but one thing is that if you take the controller as of now and plug some to the switches to all the controllers, all the applications at the top layer will get all the notifications from all the switches. Now, all the applications will get bombarded with all these notifications. Then the applications, it's up to the applications to take care of which it needs to filter and which need not. What we are trying to achieve here is that if a set of switches is connected to, say, controller 1 and a set of switches connected to controller 2, then the applications which are residing in controller 1 and controller 2 can need to only take care of those switches which that node owns, which that node is connected to. And that was the part of the cluster aware I was talking about, so that we know that, okay, if we let the applications know that these are the only notifications you need to filter on. That was the third part. And so what we can dive down is a set of discussions on design, which we can take it to the whiteboard, and I believe this is going to be a very there's a lot of discussions on this going to happen. So the very high level work items would be like, we are trying to come with an ownership service. The term can change, and I believe there's some comments on that we should name it differently, but we can come with a different name. But something like an ownership service which would decide, basically like a service which would decide that who is going to be the master, who is going to win this election. And this service, the attempt would be to also help other apps to decide which instance among the, suppose there's an app which is going to reside in all the controllers, which of my app is going to be the main instance, if at all you want just one instance of your app to be active and rest all to be passive. So I believe this ownership service can also help for that. And there is some APIs and notifications support the cluster aware apps and the custom strategies. So strategies will decide whether you want a particular controller to be the master, or what your load sharing strategy is going to be. Like if you're going to, if you want the controller which has the least number of ownerships, you can plug in that strategy and get it out. This is one of the work which is needed in the lithium design, at least, that the role requests are not implemented. It is implemented in the helium design. So the helium version of OpenFlow plugin has the role request implemented, but the roles and the underlying layer is not implemented in the lithium version. So this is one of the work which is left. And the stats is also embedded as part of the OpenFlow plugin in case of the lithium design, whereas in the helium, the stats is outside. So some work is left in the stats. And we need to work on the integration test for any of this work which we do. So that's the strategy. So the idea behind this is that this is a high-level design which we can think of and which we can discuss on as well. You have an OpenFlow plugin. So each application, even OpenFlow plugin is an application, and that will come. It is trying to gain ownership on an entity. So you will create an entity and try to gain ownership on that entity. So that will be an entity owner, and it will try to request an ownership on the SAL clustering service. This is just a new service which can be created, and this request ownership will happen, and based on that, it will try to request lock based on the strategy which has been plugged in. The strategy can be part of the entity owner itself, so that the entity owner knows that this is the strategy which I want to go with. So there's one point from Moiz was that there should be just one strategy for a particular type, not per device, in the sense that all OpenFlow plugin within a cluster will have just one strategy of clustering. It won't have different strategies based on like different devices, which is one input which at first we can take care. And there's a lock actor which will try to grant ownership based on the strategy, and the strategy will return, and based on that, the ownership response notification will be given. Based on that, each of the applications will also get a notification saying that this device is the owner for, sorry, this node is going to be the owner for this device. And that's the rule. And similarly, when a failure happens, it's a very similar scenario where the failure happens. It tries to request ownership and gets back, but it will try to also subscribe to a member down notification, because if I am not an owner for this device, then if an owner goes down, then I should be known, like somebody should notify me saying that the leader has died, so I can request for an ownership. That's the concept of the subscribe to member down notification at the very end over there. And this is in general about the entity owner, what it should be having. It should be having a name, it should be having a member ID of the name of the cluster where it's residing, from where it's coming from, and it should have an ownership strategy also along with it, which is pluggable based on how you want the election to happen. So basically the apps can steer the election the way it wants. And these are some of the things which we're planning to do, and these are the different ownership strategies. We're just trying to start simple so that things work initially and then try to add more strategies. So the basic ownership strategy would be like the first come first serve ownership strategy, which is going to come with the strategy, and then like a load shared strategy based on that, which node has the least number of owners that can try to get. So we can scale horizontally. That was the whole goal behind it, to achieve much more throughput and performance. Some SAL clustering APIs and SAL clustering service which will help us do this. Request ownership, role change notification, which might require based on the shard, if at all some apps are dependent on that. And this is just the Yang model, rough Yang model, where the entity, there's some corrections over here where the entity ID should be string, and it's kept as string, but it should be ideally an instance identifier, and a lock actor which will be created for the shard, which will extend shard, which will also persist, and the lock actor which is going to decide the election, it's going to persist its data into the actual election data in the data store. So that's why it's going to extend the shard. And these are some of the works which is left, which I was thinking about of implementations of roles and generation ID in the LI plugin, and the knob to disable stats manager, which is currently not there in the Lithium plugin, and on-demand statistics. Currently, statistics gets polled periodically, and then try to put it into the data store, which gives a lot of traffic to the controller. And if at all the inventory operational is not residing in the same node, then there's a lot of traffic across the wire. So if you can have an on-demand statistics, that would help. So this is one of the thoughts. And if you can handle some flow removed notification, I'm not sure whether we handle that off now, but that's one of the discussions. That's all I wanted to present. I think we can move the discussion to, or we can answer any questions based on this, or we can start with the actual discussions on the whiteboard, which I wanted to start 1 hour back. Okay, so I'll try to discussion on the whiteboard. But if you have any questions, please feel free to ask. And also we need more contributors. So if anybody wants to contribute or ask anything, we can help, surely. That's the actual latency which we'll have, where you will switch to a new controller. Second is that what does the master role achieve, and the slave, what the slave does. The master role, you can make read and writes both to the switch, whereas the slaves, you can just get the reads. That's what, as per the one of the controller dies, it's not that I'm making a new handshake with the switch again. There is an active connection between the switch and the other controller. So it's just going to be a role change. So there's no handshake involved, because that was one of the questions. It's not going to be having a handshake involved. There's going to be a standby connection, and I just need to revisit before we jump on to the actual discussions on the whiteboard. So what the master role does is that, so to understand is that the switches don't connect to just one controller. Each switch or a cluster of switches connect to more than one controller. So one thing guys, based like in the break, I think some people asked this question as to why we need the master role and why we need the slave role. What does the master role achieve? So I believe that this is something which, and a role change is only what is required for a transition from one controller to the other when one of them dies. How soon it's going to happen is based on the AKA cluster down event, which I'm not sure probably how much time does it take for the cluster down. It's very, very quick. Yeah, okay, so it's very quick. Yeah. So that's the